This lecture video is going to finish up section 312 that we started in class on Tuesday, and we're solving systems of linear equations. And so remember, this is a system of two equations that are both lines, and so we're looking for the place where these two lines intersect. So we're looking for a point that lies on both the lines that's also a solution for both the lines. So we're going to look at this system y equals 3x minus 10 and y equals 5x plus 14. So this is on page 395 in your textbook. So you should pause the video and get yourself to that page. And then when you find that page, hit the play button so we can see how this works. Okay, so now that you found the page, there are three methods that we're going to learn to solve systems of linear equations. The first one is graphing, and then we'll also look at substitution, and then another method called the addition/elimination method. So what we're going to do here is the substitution method. Some methods sort of lend themselves a little bit nicer to certain systems of equations than others do, and we'll talk about that a little bit here. So both of these equations right now are solved for y, and so it makes it pretty easy for us to do a substitution on this one. So I'm just going to put a rectangle around this first, the right side of this first equation. So this first equation says y equals 3x minus 10. The second equation says y equals 5x plus 14, and so we want to find some value of x and some value of y that will satisfy both of these equations. So we're going to take what y is equal to for the first equation and replace the y in the second equation with that. So I'm going to take this big red rectangle and put it into this little red box. And that'll just give me a single equation then, 3x minus 10 equals 5x plus 14. And now is all I have are x's, and so we can solve for x. I'm going to gather up all the x's on the left-hand side and all the plain old numbers on the right. So I'm going to subtract 5x from both sides of this equation. And 3x minus 5x will give us negative 2x minus 10 equals 14. I'm gathering up all the plain old numbers on the right, so I want to add 10 to both sides. That gives us negative 2x equals 24, and then divide both sides by negative 2. And so we get x is equal to negative 12. Now take what you got for x, and we'll do that in blue. We got negative 12, and you can replace the x in either one of either one of the equations from up above. I'll always just put it into the first equation, but you could replace the x in the second equation with it as well. It doesn't really matter. So I'm going to replace this x with negative 12. And so that will give me y equals 3 times negative 12 minus 10. And so we get y is equal to 3 times negative 12 is negative 36, and then minus 10 gives us y equals negative 46. So the point where these two lines intersects is the point negative 12, negative 46. You can check this answer by replacing x with negative 12 and figuring out that you do in fact get negative 46 for both of those. And that is what will happen. Okay, so basically all of these questions that you have are stepping you through how to do this. So I'm basically ignoring how they're asking me to slowly step through it, and I'm just solving it. Okay, so now we're skipping a bunch of problems. We're going to skip down to number 8a. So this was the system of equations that we had gotten from the word problem at the beginning of this section. And so if you need to go back and review that, and look at how we came up with these two equations. So now we're going to use the substitution method to solve this, and both of these are solved for C already, and so we're going to do exactly what we did before. We're going to take 0.17x plus 11, and we're going to put that where this C is right now. So we'll have 0.17x plus 11 equals 0.22x plus 4.10. I'm going to gather up the x's on the left and the plain old numbers on the right, so I'm going to subtract 0.22x. And 0.17x minus 0.22x is negative 0.05x. And then we have plus 11 from right here. And it's going to be equal to 4.1. You can write the 0, but you don't really need it. And then I'm going to subtract 11 from both sides. We get negative 0.05x equals negative 4.1 minus 11 gives us negative 6.9. And I'm just going to double check my other subtraction there. Yep, I was right. And then divide by negative 0.05. And we get x is equal to 138. All right, so now to figure out the cost, we plug what we got for x, 138, into x in either one of the equations. Again, when I'm doing them to show you, I'm always going to use the first equation, but you could very easily use the second equation as well. So we'll plug that into there, and we'll get c is equal to 0.17 times 138 plus 11. And 0.17 times 138 gives us 23.46, and then plus 11 gives us a cost of $34.46. Okay, so remember, this was somebody was starting up a small business or something like that, and they were looking into two different accounts, a basic account and a regular account, and so this is where both of those accounts will cost the same, as if you make 138 transactions in a month, and your total cost then would be $34.46. So I'll just write that out. So both accounts will cost $34.46 if you have 138 transactions in a month. Alright, so we're going to skip a bunch of these problems, and so number 9 is giving us another word problem, so we'll take a look at this. It'll be nice for us to get into setting up some of these equations from the word problems. So your part-time business is growing to a full-time operation. You need to purchase a car for deliveries. An American Express car costs $13,600 and depreciates $500 a year. Write an equation to determine the resale value V of this car after X years of use. Okay, so we want a value equation, so we want to use V. So V of X, the initial value is $13,600, and then it's depreciating or losing value each year, and it's $500, so it would be minus 500, and then times X, the number of years that you've owned it. Okay, so a Japanese car costs $16,000 and depreciates $800 a year. Write an equation to determine the resale value V of this car after X years. So again, we're going to have a V of X equation. Here's our starting value, 16,000. And then it's depreciating, so that means we're subtracting off, and it's $800 each year, so that would be $800 times X, the number of years that we've owned the vehicle. Write a system of two linear equations that can be used to determine in how many years both cars will have the same resale value. And so the system, well, let me try to write a better brackets than that. That's a little bit better. So it would be just both of these equations written with this set symbol there. It's saying we're going to consider both of these equations at the same time. So the value after X years is equal to 13,600 minus 500X for the American car, and V of X equals 16,000 minus 800X for the Japanese car. Excuse me. We're going to skip filling in this table, and we're going to look at solving the system graphically. So we want to, I'm going to write these equations down so that we can see them. V of X equals 13,600 minus 500X, and then over here I'll write the other one out. V of X equals 16,000 minus 800X. Okay, so notice in both of these we have this initial value, the cost of the vehicle, and then after that as time goes on, we're going to be taking money away from that because they're depreciating in value. So our lines are going to start up here on the y-axis somewhere, and they're going to go down. So 16,000 then is the biggest I need to go on my y-axis. And I do want to go all the way down to 0. I don't know how long that's going to take, but I do want to go all the way down to 0. So 16,000 is the largest that I need to be on my y-axis, and I actually want both the y-intercepts and the x-intercepts, so this is going to be v of x, or the y, and this is x. And so I want to figure out when this value is going to reach 0. So how long is that going to take? So that would be my x-intercept. So that means that I want this v of x to be 0. So 0 equals 16,000 minus 800x. So I'm going to subtract 16,000 from both sides. Can't really see that very well, but negative 16,000 equals negative 800x, and then divide by negative 800 on both sides. So these two zeros would cancel with these two zeros, and 160 divided by 8 is 20. So it'll take 20 years for that to have a value of nothing. And then we know what the y-intercept is. So the y-intercept is the 16,000. That's its value when we purchase it. And then we're going to do the same thing for the other equation. So we want to find the x-intercept. So when does this car have a value of nothing? So this was 20, 0. So do the same thing. Replace the v of x with 0. Gives us 0 is equal to 13,600 minus 500x. Subtract the 13,600 from both sides. We get negative 13,600 equals negative 500x. Divide by negative 500 on both sides. And what do we get here? $27.2. Let's see. And I did do my calculation correctly. So that would be 27.20. So I need to go up to 30 on my x-axis, and I have 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15. All right, so I'm going to use 2 units for each. So that'd be 4, 8, 12, 16, 20, 24, 28, and 32. And on my y-axis, I need to go up to 16,000. That's the larger of the two starting values. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 to do it in. So each of these will be worth 1,000. All right, so let's graph our first line here in black. And so it's v of x-intercept or y-intercept was at 0, 1600. Or 16,000 rather, sorry. And then its x-intercept was at 20, 0. And then we can draw this line in. Let's see. I'll try to use a straight edge so that maybe my graph will actually look fairly decent. All right. So there's my line. I'm a little bit off, but that's okay. And then we'll do the other graph in red. And so there we have 13,600. So that'd be a little more than halfway between 13 and 14. And then we have 27.20 for the other intercept. So it's just a little bit bigger than 27. Let's try to make my dot kind of big. And so there's that line. And so right about there is my intersection. Excuse me. And so the graphing method really isn't great for this one, and it's not great because it's happening at this weird place. It looks like it's happening at about 8 years, that would be my guess. Where the value of these two vehicles would be the same. But I'm not really sure. So one way we could check that is just to plug 8 into both of our equations and see if we get the right amount. So that would be one thing that we could do. We could also just solve these two equations using the substitution method. So you would take this, 16,000 minus 800x, and set it equal to this. So that would be writing out that one equation. Okay, and so that would be equal to 13,600 minus 500x. So we're going to gather up the x's on the left and the plain old numbers on the right. So I'm going to add 500x to both sides. That would give me 16,000 minus 300x equals 13,600. And then we're going to subtract 16,000 from both sides. So we'll have negative 300x equals negative, let me check this, negative 2,400. And then we're going to divide by negative 300. And we do get x equals 8. So my guess was correct on that. So my graph isn't too bad, I guess. So it's going to take 8 years. And then to figure out what the value will be after 8 years of each of the vehicles, you can just plug that 8 into either one of those equations. And so I'm going to plug it into this equation right here. So 13,600 minus 500 times 8. We get 13,600 minus 4,000. And again, I'm just going to check my numbers. So and that ends up giving us a value of 9,600. And I don't know if I would have guessed that from my graph or not, but maybe. Okay, so again, graphical, you have to have a special kind of system in order for the graphing method to work very well. So here we're going to solve this system using the graphing method. And so when we graphed our other two lines, we used the intercepts. We had the y-intercept, and we wanted to know at what point the value was going to be 0 for each of the vehicles anyways, so we used both of our intercepts for the last problem. This one we have the slope and the intercept, so we're going to use that information. So the first line, y equals 2x plus 2. So m is 2. And b is also 2. That's this 2. And so that means that my y-intercept is the point 0, 2. So there's my y-intercept, and my slope is 2. So we could go up 2 and right 1. Or we could go down 2. And then we would have to go left 1. So up 2, right 1. And I'm going to label my points 0, 2, and this would be the point 1, 4. And then I'm going to go down to left 1 for my other point. So that's the point negative 1, 0. And then I'm going to draw my line. Now in red, I'll do the other graph. So that was y equals 2x minus 1. Again, my slope is 2, just like it was for the last line. B is equal to negative 1, and so that means my y-intercept is the point 0, negative 1. And again, my slope is 2, so I can do either one of these two things. So because I need to get up to the black graph, I'm going to go up to right 1 both times. So I'm going to go up to right 1, and then up to right 1 again, and then up to right 1 again. And what do you notice is happening here? Well, I can keep on going, and then I could go down to left 1, down to left 1. And no matter how long I keep doing that, my graphs are never going to cross. If two lines never intersect, it means that they're parallel. And the answer, whoops, the answer to our problem here is that there's no solution. All right, so we have three methods for solving these. We have the graphing method, which we just looked at and we'll look at again. We have the substitution method. We're going to do the same problem for both of those. And then we have the addition/elimination method, and we have a separate problem to go through for that. So when you're using the graphical method, we're going to graph both lines on the same coordinate. So I'll graph the first one in black and the second one in red. So my y-intercept is 3. So 0, 3 is my y-intercept, and my slope is -1/2. So that means go up 1, left 2, or down 1, right 2. Either way. All right, so I'm going to go up 1, left 2. That would bring me to the point -2, 5, no 4. And then I'm also going to go down 1, right 2. And so that brings me to the point 2, 2. And then I can draw my line in. Okay, now the next one here is not in the y = format. This is in standard form. And so for this one, I'm going to find my two intercepts. And so the way that you find your two intercepts when you have a standard form line, -x plus 2y equals -2, I believe it was. Yep. So we want to find these two intercepts, and it's always the opposite variable is 0. So for the x-intercept, y is 0, and for the y-intercept, x is 0. So if you plug 0 in for this, then this term is just gone, and you end up with -0. Oops, sorry. I was doing the y-intercept. We're putting 0 in for y, so this would become 0. -x plus 2 times 0 equals -2. So this term just ends up being gone. And what I do when I'm sitting at my desk is I just cover this up with my finger, and I just see -x equals -2, and that tells me that x has to be equal to +2. So 2, 0 is my x-intercept. Then do the similar thing for the y-intercept. So now I'm going to let x be equal to 0. So -0 plus 2y equals -2. So now this is 0. So all you're left with is 2y equals -2. Divide by 2 on both sides, and we get y equals -1. So we have 2, 0. And 0, -1. And then we can draw our line. And so here is the intersection point, and the intersection point is at, the intersection point is a 0.41. Okay, so that was the graphical method. Now we're going to solve the same equation, only this time we're going to use the substitution method. This one lends itself nicely to the substitution method because this first equation is already solved for y, which makes it nice for substitution. So here's what y is equal to. It's equal to negative 1/2 x plus 3. So we're going to take that and we're going to put it into the y in the second equation. So we're going to take this big rectangle and we're going to put it where the little box is. So we'll have negative x plus 2 times what y is equal to negative 2. Y is negative 1/2 x plus 3. So to solve this, for x, the first thing I have to do is distribute this 2. We have negative x, and then 2 times negative 1/2 is negative 1, so that would be minus 1x, or x. And then 2 times 3 is plus 6, and it's equal to negative 2. So now I have negative x and negative x is negative 2x. And then I'm also going to subtract this 6 from both sides. And we get negative 2x is equal to negative 8, and then divide both sides by negative 2. So that gives me x is equal to 4, just like we had when we graphed it. We got x equals 4. And then take what we got for x, 4, and I'm going to plug it back up into the x in the first equation. You could plug it into this x if you prefer. So that will give me y equals, now I'm plugging this 4 into this x, so negative 1/2 times 4 plus 3. So y equals negative 1/2 times 4 is negative 2, plus 3 gives us y equals 1. So we have the point 4, 1 as our solution. In the last one here, we're going to use something called the addition or elimination method. And here we want to add the two equations together so that when we add them together, we get rid of one of the variables. So we want the same number in front of the variable but opposite signs. So I already have opposite signs for the y's, so I'm going to get rid of the y's. And it's just like finding a common denominator. If you had a fraction 1/3 and 1/2, what would you use for your common denominator? 6. So I want to multiply both of these equations by something so that I get a 6 in front of the y's. So I want to multiply the first equation by 2 and the second equation by 3. So when I do that, I'll get 4x plus 6y equals 22. Just be careful that you multiply every single thing in the equation by the number. And then when I multiply the second equation by 3, I get 9x minus 6y equals negative 48. And so now I can add these two equations together, and the y's will be gone when I do that. So 4x plus 9x is 13x. 6y and negative 6y is nothing. And then 22 minus 48 is negative 26. And then we're going to divide by 13 on both sides, and we get x equals negative 2. So now with the addition elimination method, you can take what you got for x and plug it into either one of the two equations that we started with. I'll always just plug it into the first one. So that's going to be 2 times negative 2 plus 3y equals 11. So 2 times negative 2 is negative 4, plus 3y equals 11. I'm going to add 4 to both sides, and I get 3y equals 15, and then divide both sides by 3. So we get y is equal to 5. So our solution here is the point negative 2, 5. Alright, so that is it for this lecture. Let me know if you have any questions, and we will be doing a review when we get together next time. And so make sure that you can be there next Thursday. It'll be really important. We'll be reviewing for test 3, and we'll also be getting ready for game night with the kiddies. So I hope you're having a great weekend. We'll talk to you soon. Bye.